All right, here we go. Let's talk about names. We've talked about REPL, where we'll write our code. That is our IDE. We did some arithmetic in the console last time. So now let's talk about names, or as I said, these can also be called variables. Now, when we did our work in the console, like we typed in 2 plus 2, that got evaluated and the value got printed to the console, and then we looped back. Of course, we know about that. But focus on a word that I just said. I said value. Okay. The value of this expression 2 plus 2 is 4. And let me go ahead and show you something. How about the value of the expression 2? That will be evaluated, and then that value will be printed to the screen. You might think it's like, well, there's nothing to be done, right? So perhaps nothing will be printed to the screen. Well, this is false. The, the part where nothing will be printed to the screen, the part, however, where nothing has to be done, I suppose that's true enough. We don't have to do like any sort of compression kind of work where 2 plus 2 becomes 4. But still, that expression has a value. It is itself. That's called a literal, okay? And we can even type in what we saw a couple of days ago. Type in a string if we want to, and then it gets repeated back to the screen, in this case with single quotation marks. For us in this context, that doesn't make any difference. But everything that we've typed into the console, that doesn't result in an error anyway. What we get back in the console is a value. Now, what we can do is this. With those values, we can give them names, okay? So, I don't know. Let's give a name to 2 plus 2. How about, I don't know, result addition? Okay. RES is just short for result. And notice that there's an underscore here, and I will come and talk to you about that in just a moment, why that's there. So type it in just like you see it. Okay, so result addition is 2 plus 2. Okay, so I'll tell you what, I'll go ahead and type that into the console. Okay, so, oh, we've got a little mystery here, don't we? Nothing was actually printed out on the console. So apparently there was no value to this expression, nor did we get an error message, okay? I mean, if Python doesn't know what to do with it, we get one of those bright red error messages that look so incredibly bloody. But we didn't get that, so Python was perfectly happy with this. So Python did something. What is the something that Python did? Well, what Python did is this, is it gave a name to the value of the expression 2 plus 2. Okay, and how can we see that? Well, let me type in the name. Okay, so res addition, spelled exactly the way that we saw it named before. If you spell it differently, you'll get an error. Oh, and that's 4. Okay, so do you see what happened here? This is actually one of the most important moves that we make all year long. Okay, so we had that res addition equal symbol actually. I'm about to request that you not call that the equal symbol, but we'll call it that for now. Res addition equal symbol 2 plus 2. What happened is this, is that Python evaluated the right-hand side, that is the 2 plus 2, that of course resulted in floor, and then made res addition a name of that value 4. And then if I type res addition into the console, what Python will do is tell me the value of that name. Okay, that is the object that it names, which is 4. What I just did here, perhaps I'll use different language to describe it for you, old and common language. What just happened here is this, is we assigned a value to a variable. Okay, so what I called a name, res addition, could also be called a variable. So what we did is we assigned a value to the variable. So the variable res addition was given the value that resulted from the evaluation of 2 plus 2, and that value is 4. And then when I typed res addition into the console, that variable, Python simply reported back the value that it holds. Okay, the value that it holds, which is 4. Okay, so names. Now, you might think to yourself, well, why do we need names? And memory is the answer. Okay, it allows us to remember values. So we're about to go over to the code editor and to show you just how extraordinarily useful names can be. All right, so before we actually go and do that, perhaps I should say a word about how it is that names have to be spelled. That is, variables have to be spelled. The complete rules for this, I mean, you can Google them if you like rules for name formation in Python. I'm sure that would work just fine. You can find it on my website as well. But the basic rules are these. Okay, so the symbols that you can use in a name, that is a variable. You can use letters, either lowercase or uppercase, and it's certainly case sensitive. Okay, that is like uppercase R is different from lowercase r. You can use digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can use the underscore, and that's it. Okay, so letters, numbers, and the underscore is all that you can use, and you can't start with a number. Okay, you can't start with a number. Now, there are actually other rules that are one of the rules that's in effect as well. There are certain words in Python that are already set aside in Python for its particular use. We've seen one of them already, that is the print function. So if you were attempt to use that to name a value, well, actually we do get a value for that, and then that's actually really bad. Oh, actually, I'm sort of surprised that Python did this for us. So here's what happened, and it's really quite evil. So Python did allow us actually to use print, which we know is a function that's already defined in Python, right? To name as a name of the value 2 plus 2. And then I typed in print and we got 4. And then when I tried to use the print command, which I could have used had I not redefined it to mean 4, I actually get an error. So you have to be very careful about this. In some instances, when you attempt to use a name that Python has already defined, you get an error message. In some cases, apparently it allows you to overwrite, but then it means something different than what it ought to mean, and that can certainly lead to errors. These words that Python have already defined and you ought not to use as names of values, that is, as variables, these are called keywords. And I've got some examples of keywords in chapter 1. You can simply type in Python keywords as well into a Google search box, and you'll find the complete list of those. So that could potentially be a problem. There are lots of keywords in Python of which you know nothing, I expect. And if you have some trouble with the name of a value, perhaps it's because you've chosen a keyword. You can always do a search for that. But in general, the rule is this: you can use letters, you can use digits, you can use the underscore, and you can't start with a digit. And these are how we form names. Now, back to the question about why we want to use names. Now, why do you want to use names? Memory, okay? They are the basic way that we actually store values away in Python. It's not the only way that that can be done, but it is like the standard first way that that can be done. So let's go over to the code editor and write a little bit of code. Okay, so let's say that we wanted to write some code. I mean, code is supposed to do something for us, right? I mean, ultimately what code does is automate processes that we could carry out by hand, but they're much too labor intensive. They're much too tedious to do that. So it's all about automation ultimately. So, you can automate arithmetical processes like, I don't know, how about the computation of the area of a circle? The area of a circle is given by the expression pi r squared. And I tell you what, I'll actually note that in my program, and I'll do so with a comment. This is a good comment, a good context. I'm going to introduce the idea of a comment. We have seen lines of code in the code editor before that were executed. When we hit the run button, you remember we printed 2 plus 2 and 2 minus 3 and hello world. And the results of that were they appeared in the console. You can also type into the code editor, but indicate that this is not actually code. And Python will simply skip over it. And you do that with the hashtag. Okay, so the area of a circle is pi times radius. So just a little comment, just to give the reader of the code some sense of what it is that the code actually is about, and gives us would also inform the reader of what the formula used will be if the reader happened not to know it. And again, this is not a line of code that will be executed because it is preceded by the hashtag, and said Python will simply skip over that. It is for the human reader of the code, which could be you at a later time. And we'll talk in great detail about why it is that you would want to comment code and how you should comment code. It's really quite important. Okay, so let's see. I don't know. How about this? I'm going to print some stuff, right? So how about we will print the area of a circle of radius. Show you something else with the print command. This is something that you should know. I can print multiple values on a single line, and if I do that, I separate them by commas inside of the parentheses after a print. So the area of a circle of radius 5 is, and then comma. Notice that some of the objects that I have printed here are strings. Notice that the area of the circle of radius, that's a string, right? It's contained in quotation marks, so those words will be printed exactly on the screen. And then the number 5 will be printed. And then is, the string is will be printed. And then we will print, well, pi r squared, right? So let's use that approximation for pi. Pi times 5 squared. And again, Python does know the proper order of operations, and powers come before multiplication. So Python will do 5 squared, and then we'll multiply that by 3.14159. Okay, so let's actually make sure that this works. And something that will happen very commonly when we write code in the code editor, or when I write code in the code editor to show you, something will be wrong with it, and then we'll have to go back and fix the mistakes. This is just the life of a programmer. Everybody makes mistakes, and you have to go back and fix them. So let's see. Oh, nice. It actually worked. The area of circle of radius 5 is 78.53975. I hope that is correct. So we could also, if we wanted to, go ahead and do it again. Notice something that I've done in the code editor. I have empty lines where I just simply hit return. So line number 2 is empty, line number 4 is empty. This is not necessary, however, it is highly suggested that you do this. It helps the reader. Remember I said in our discussion of arithmetic in the console that very often I'll put, for instance, a space before and after a plus symbol. That's just for readability. Python doesn't care. It helps the human reader to chunk up what it is they see and so understand it. The same is true with empty lines in the code editor. It helps the human reader to read it. It's a bit like punctuation. Okay. All right. So let's do another one. So how about this? I'm going to copy paste a little bit. So select Control C, then Control V. I'm sure that you know about Control C, Control V. So the area of circle of radius, I don't know, 12 is 12 squared. Okay. It's 12 squared. And then we could run it. Oh, and then we get both, right? We get both. So that's really quite nice. So you can see the automation aspect of the code that we've written, right? It automates something that we could do ourselves. You could certainly by longhand carry out this operation, though nobody, of course, wants to do that. It's extraordinarily tedious and error prone as well. Another reason that we wish computers to do our work for us is that it is much less likely that the computer will make a mistake than that we will make a mistake. So yeah, we could absolutely do it like this, but let me show you another way to go about this. Okay, let me show you another way to go about this. I'll tell you what, I'm going to give myself a little bit more room. If you hit the top left files symbol, it collapses that left-hand pane so you can get a little bit more space. And I tell you what, here's something that often I will do when I wish to deactivate code. Simply put the hashtag in front of it. That is the comment symbol. So that entire line is now a comment and will not execute. And I can prove that to you if I hit the run button. So I just hit the run button and none of that executed. So I didn't want to get rid of it. Okay. If you ever want to like deactivate code, but not simply delete the code, you can put the hashtag at the front of the line and it is now deactivated, though it still exists. So if you want to reactivate it, you just simply, of course, delete the hashtag. All right. So let's do this in another way. Okay. Let me actually the name to the value 3.14159, or to use that alternative language, let me give a value to the variable pi. And a side note here, notice that I've capitalized this. Typically, programmers capitalize variables when they mean to say that those variables are really constant. Okay, that is, I'll never change the value that's been assigned. It's certainly possible to change that value if you like, as we'll see in just a moment. Any name can have a different value assigned to it in Python. But if we intend not to do that, often we capitalize. So there it is, pi, 3.14159. And then how about I give a value to radius? Okay, so radius is 5. So here's what I would like to do. Oops, I better make this a string. So the area of circle, about A, I'll make this a little better, a circle of radius, and then, I'm just going to type simply R. We'll come and talk about this, though I suspect you know what's going to happen. And notice that R there is not in quotation marks. It is not a string. It is the variable, okay? Is, then I'm going to do a computation. So pi times R squared. Okay, so let's actually see this work. The area of a circle of radius 5 is, yep, that's the value that we saw before. So look at that somewhat complex print statement. Well, we print 4 objects. First a string, the area of a circle of radius, and then the value of the variable r. That's what you do when you print a variable. Its value appears on the screen. Then the string is, and then you see the pi times r squared, pi r squared. And you can't simply go pi and then immediately after r squared. You need the multiplication symbol. In math, you can drop it, but in Python, you absolutely cannot. You can try if you like, it'll result in an error message. But that expression inside of the print statement, it's very much like the REPL, how the REPL works. That expression will be evaluated, and then the value of that expression will be printed to the screen. And it was. The value of pi r squared is 78.53975. And how should we think about how that works? The way that I think about it is replacement. Okay, so when Python encounters pi r squared, pi times r squared, it replaces the variable pi with its value. That is, it replaces pi with 3.14159, and it replaces r with its value, which is 5. And then it does the computation, okay, and results in the single values, 78.53975, and that gets printed to the screen, okay? So this is a really important example for us, okay? So it shows how it is that we can assign a value to a variable, and then we can use that variable name in later computations, okay? So it's memory, right? It's memory. And here's something else that we could do as well. We could actually assign the result of the computation to a variable, pi times r squared. And then here's what we could do. Okay, the area of a circle of radius r is a. Okay, so let's run that. And hey, we get the same output. And what happens in this case? Well, pi gets its value, r gets its value. And then how does line number 9 work? Well, it does the computation that's indicated on the right-hand side of the equal sign. And I suppose I should go ahead and tell you what the name of that really is. I will in a second. And then that value is assigned to a. And then on line number 10, we print out these 4 values, a string, and then the value of r, and then the string is, and then the value of a. Okay. Oh, yeah. So let me go ahead and say this. I probably should have said it before. What I've called the equal sign, like pi equals 3.14159 and r equals 5 and so on, that really should be called the assignment token, because what it is used to do is to assign a value to a variable or give a value to a name. Say it either way. Okay. It is not really the mathematical equal sign. Okay. It is the assignment token. And what you have to understand is that Python always works in the same way with an expression like that, okay? That is, it evaluates what is present on the right-hand side, like for instance on line number 9, where we evaluated pi times r squared, where pi became 3.14159 and r became 5, and then the work was done. And then after that evaluation of the right-hand side is done, the value that results is assigned to the variable on the left-hand side. Okay, that's just always how this works. So quick review. This is actually really, really important language. On line 7, 8, and 9, we have variable assignment statements. Okay, that is, we give values to names. The way that it always works is this, is that the name, that is the variable, is on the left-hand side. The value comes from the right-hand side. And if the right-hand side needs evaluation, then initially it is evaluated, like in line number 9, and then the value that results is assigned to the variable or the name that occurs on the left-hand side. Okay, so that's how all this works. And let me point out something to you as well. It's entirely possible to redefine variable, that is to give it a new value. So I will do that. And I tell you what, line number 10 is exactly what I need again, so I will simply copy paste it onto line number 14. But notice what I have done. I have redefined the value of r, okay? And then I have recomputed the value of a for that new value of r, and then I have printed the results to the screen on line number 14. Okay, and there it is. I believe that's the same number that we got before. And this works in the same way as it did, right? So r gets the value 12. That is, r is assigned the value 12. That's the assignment token there. I'll highlight it. And then on line number 13, we do the computation. There's the assignment token again. So we do the computation that is indicated on the right-hand side. And we do that, we substitute for pi its value, r for its value, and then we, do the math. And then the result is assigned to a. And then on line number 14, these various values are printed out one after the other. Okay, and then you can see that in the console. You can see that in the console. So again, let me emphasize, What do variables do for us? They store away values. And that can be quite extraordinarily convenient, right? So for instance, here's a really good example of that. I defined pi up at the start as 3.14159, and then I can simply use pi wherever I want, right? I don't have to type in 3.14159. It is quite a bit shorter. Oh, and here's something else as well that's really, really cool. Let's say that I actually wanted greater precision on the pi. So 3.1415926, I think that's how it goes. We'll pretend that's right. So let's say that I wanted greater precision. Well, I only need to change that in one place, okay? So I've changed it now on line number 7, and that means that the value of a pi that is used later on, like on lines number 9 and lines number 13, will be that new value. So I only have to make the change in one place. And you can see over in the console that, yeah, we now have greater precision in the computations that we did. So what do variables do for us? They're memory, right? We can store values away. And they also make it easy to change the values that we wish to use, because perhaps, like in the case of pi, we've defined it in one place, but use it in multiple places. To make the value used differently, we need to change it in only one place. Okay, so that's the basic story about names, that is variables, and the assignment token and evaluation, and how it is that variables get their values. This is certainly something that we will talk about again, because this is one of the basic ideas in the class. So do not be surprised when I return to these ideas.